Hi, and welcome to Dr. V's AP Chemistry webcast. I'm Dr. V, and in this webcast, we're going to use the first order integrated rate law to solve a problem. So what I want to do is first discuss key features of the first order integrated rate law. If you know what all the parts are, it's a lot easier to recognize and it's a lot easier to use. And then we're going to work through a practice problem together. When you have first order kinetics, you can use the first order integrated rate law to solve problems to find out how much change occurs in a certain amount of time. You do need to know that it's first order. This equation is on your reference sheet, so you always have access to it. When we say ln of AT means the amount or concentration of substance A at time t, and then we have to take the natural log of that. The second part of the equation is ln of A naught. A naught is the amount or concentration of substance A at time 0. And of course, we take the natural log of that. K is the rate constant for that first order process. There is a relationship between K and the half-life for a first order process. If you know the half-life, you can calculate K. That's on your formula sheet too. And finally, T refers to the amount of time that has elapsed for the process. So now we're ready to work through a problem. Consider the following chemical reaction. Let me show it to you. Methyl isonitrile has the formula CH3NC, and we have a picture model of it here. It undergoes a reaction to make CH3CN, which is known as acetonitrile. So it's a very subtle change, CH3NC to CH3CN. The reaction is known to be first order in methyl isonitrile, CH3NC, and the rate constant is this really small number, 0.000051 inverse seconds. It's first order, so the rate constant has units of inverse time. How many minutes will pass until only 29% of the original methyl isonitrile remains? So we know the reaction is first order, and therefore we're going to use the first order integrated rate law, and not the second order integrated rate law, and not the zero order integrated rate law. You have to use the rate equation for the rate problem. I find when I'm doing these fairly involved problems that it makes a lot of sense to list what I know and really write out my variables and pull that problem apart. So what I'm going to do here is set A naught to be 100% and AT to be 29%. So I'm starting at 100. How much time did it take for me to get to 29%? And the beauty of the first order integrated rate law is I don't have to have whole number intervals for the number of half-lives that elapse. We're given K, the rate constant, and we want to know how much time it took. This is what we know from the problem. There's one other thing I want to point out though. Look at the units for K. It's inverse seconds, but I'm asked for the time in minutes. I've got to make these time units match in order to do this problem successfully. And if you miss that, your answer is not really going to make sense. So one strategy is that I'm going to solve for the time in seconds and then convert to minutes. And that's what I'm going to do when I do this problem. I suggest that you pause the video at this point and see if you can solve it on your own before you watch my solution. Okay, we've got the first order integrated rate law. We know what the variables are. Let's rearrange it to solve for t before we substitute in. I always recommend this strategy to my students. So if I divide both sides by negative k, that will give me time, which is what I'm solving for. It'll give it to me in seconds. And at this point, we can now substitute and evaluate. Remember, we decided A naught was 100%, AT was 29%, we're given K. So we have to just substitute and evaluate. All right, so ln of 29 minus the ln of 100 divided by the rate constant will give us the time in seconds. So I'm going to take the natural log of 29, the natural log of 100, substitute that in. I'm just showing you all my work as we go, simplifying, and finally doing my division. And I get an answer of 24,375 seconds. However, the question wants to know the time in minutes, so I have to convert from seconds to minutes. So I'll divide my 24,375 seconds by 60, because there are 60 seconds in a minute, and I get an answer of 406 minutes. I'm going to argue that I really can only give this answer to two significant figures, so I'm going to report it as 410 minutes. AP Chemistry students need to be comfortable solving problems using the first order integrated rate law. You need to be able to work through it, set it up, do these problems comfortably. They are fair game on the AP Chemistry exam. The other thing you want to pay attention to is that there are a lot of different ways to word these problems, and you need to work through them carefully and make sure you set up your variables correctly, that you're solving for the right thing, that you're in the right units, that your time units match, and really pay attention to those little details if you want to solve these problems successfully. You can do them. You just need to practice just like with any math problem. If you found this video to be helpful, like the video and leave a comment. And please subscribe to my channel so you get all my latest updates. Keep practicing chemistry. Practice every day. Do your problem sets. That's how you get better.